Hello student, I am Mayur Gondalia and you are watching School of Physics. Today we will take one more example on Fourier series with period 2 pi. The problem is obtain a Fourier series to represent the function f of x equal to minus sin x for minus pi less than x less than 0 and f of x equal to sin x for 0 less than x less than pi, or f of x equal to modulus of sin x for minus pi less than x less than pi. It is clear from the expression of the function that it is even function, yet you cannot decide about it, then follow this process. Let f of x equal to minus sin x for minus pi less than x less than 0, say equation 1. Take x equal to minus x. Therefore, f of minus x equal to minus sin of minus x for minus pi less than minus x less than 0. Now, in given interval, we want to change the sign of minus pi and minus x, and that's why we replace less than sign by greater than sign. Therefore, f of minus x equal to sin x for pi greater than x greater than 0. Now, inverse the order of interval. Therefore, f of minus x equal to sin x for 0 less than x less than pi, say equation 2. For another part of the function is f of x equal to sin x for 0 less than x less than pi, say equation 3. Take x equal to minus x. Therefore, f of minus x equal to sin of minus x for 0 less than minus x less than pi. Now, in this interval, we change the sign of minus x and pi, so simultaneously we must have to change the less than sign also. Therefore, f of minus x equal to minus sin x for 0 greater than x greater than minus pi. Here sin of minus x, that is minus sin x. Now, the interval is rewrite in inverse order. Therefore, f of minus x equal to minus sin x for minus pi less than x less than 0, say equation 4. Now, it is observed from equation 1 and 4 of interval minus pi less than x less than 0, and from equations 2 and 3 of interval 0 less than x less than pi, that f of x equal to f of minus x, that is given function is even, and therefore coefficient Bn equal to 0. So, we will calculate only coefficient a0 and an. For a0, the formula is a0 equal to 1 upon pi integral minus pi to pi f of x dx. Function fx is even. Therefore, we will write a0 equal to 2 upon pi integral 0 to pi f of x dx. Putting the value of f of x for interval 0 to pi, a0 equal to 2 upon pi integral 0 to pi sin x dx. Here integral sin x is minus cos x. Therefore, we get a0 equal to this one. Putting the limit of integration pi and 0, therefore, a0 equal to 2 upon pi into bracket minus cos pi plus cos 0. Here cos pi equal to minus 1 and cos 0 equal to 1. Therefore, a0 equal to 2 upon pi into minus 1 plus 1, and therefore a0 equal to 4 upon pi. This is the value of coefficient a0. Now, the formula of an is an equal to this one. Here, this fx is even and this cos nx is also even. Therefore, product is even. Therefore, we can write an equal to 2 upon pi integral 0 to pi f of x cos nx dx. Putting the value of f of x, an equal to 2 upon pi integral 0 to pi sin x cos nx dx. take 2 inside the integral. Therefore, an equal to 1 upon pi into this. Using trigonometric relation, 2 sin a cos b equal to sin a plus b plus sin a minus b. In this expression, x equal to a and nx equal to b. Therefore, a plus b equal to x plus nx equal to 1 plus n into x, and a minus b equal to x minus nx equal to 1 minus n into x. Therefore, the equation is written as an equal to 1 upon pi integral 0 to pi into sine of 1 plus n into x plus sine of 1 minus n into x into dx. By integrating, we get an equal to this plus this, where integration of this term is this one and integration of this term is this one. Now, substituting the values of integration, we have an equal to 1 upon pi into minus cos of 1 plus n pi plus cos 0 upon 1 plus n plus minus cos of 1 minus n into pi plus cos 0 upon 1 minus n. Since cos of 1 plus n into pi equal to cos of pi plus n pi, that is equal to minus cos n pi, and cos of 1 minus n pi equal to cos of pi minus n pi equal to minus cos n pi, and cos 0 equal to 1. Therefore, our equation becomes an equal to 1 upon pi into cos n pi plus 1 upon 1 plus n plus cos n pi plus 1 upon 1 minus n. Simplifying it, we get an equal to 1 upon pi into this. These terms are the multiplication of these two terms, and these terms are the multiplication of these two terms. This part of denominator is obtained by multiplication of these two terms. Minus n cos n pi cancel with the plus n cos n pi and minus n with plus n. Therefore, an equal to 1 upon pi into 2 cos n pi plus 2 upon 1 minus n square. Therefore, an equal to, taking 2 common, 2 into cos n pi plus 1 upon pi into 1 minus n square, and which is equal to 0 for n odd, because if n odd, then cos n pi equal to minus 1, and therefore cos n pi plus 1 equal to 0, and therefore an equal to 0 for n odd. And if n even, then cos n pi equal to plus 1, therefore cos n pi plus 1 equal to 2, and therefore an equal to 4 upon pi into 1 minus n square for n even. This is the value of coefficient an. Now, Fourier series is f of x equal to a0 by 2 plus this one. Our function is even, therefore bn equal to 0, hence this term is removed, and an exists only for even values of n. Therefore, we can write f of x equal to a0 by 2 plus summation n equal to even an cos nx. Substituting the values of coefficient a0 and an, we get f of x equal to 1 upon 2 into your value of a0, that is 4 upon pi, plus summation n equal to even value of an, that is 4 upon pi into 1 minus n square into cos nx. Simplifying, we get f of x equal to 2 upon pi minus 4 upon pi into summation n equal to even cos nx upon n square minus 1. Expanding it by taking n equal to 2, 4, 6, etc., we get f of x equal to 2 upon pi minus 4 upon pi into cos 2x upon 2 square minus 1 plus cos 4x upon 4 square minus 1 plus cos 6x upon 6 square minus 1 plus so on. This is the required series of the given function. In next video, we will take one more example of Fourier series with period 2 pi. Please write your suggestion in comment box, like and share this video, and subscribe my YouTube channel, School of Physics. Thanks.